Hello, physics class. I miss you a lot, and I have to do. I'm going to give you a couple brief videos after spring break. I'm hoping to maybe start doing Zoom lessons, but for right now, I'm going to have these brief videos. They're going to go very quickly, so if you want to watch them more than once, that will help. First of all, most of the stuff is going to be on chapter 4. So let's go with motion 1. Uniform motion means you're going at a constant speed, and we use the speed equation for that. Now, this is kind of like algebra stuff, but speed equals distance over time. That's pretty easy there. You can rearrange it. Speed times time is distance, or time equals distance over speed. Now let's think about that. If you look at the proportionalities, if speed were to be held constant, time and distance are directly proportional. So if you were to travel twice the amount of time, you go twice the distance, and etc. So you know how to do proportionalities like that. So if you were to see a graph like this, distance and time, you say, well, what's the slope of that line? The slope is y over x, or d over t. What is d over t? D over t is speed. Now, not only is it speed, the slope of a straight line is constant. This is, believe it or not, constant speed. Even though you see a line going up, the slope itself is constant. That's what it would look like in a graph. And look over here, what it would look like if you could look at an object once every second. It would be covering the same amount of distance in the same amount of time. That's called constant speed. Now, if you go down here, what if this? What about distance and speed? What would distance over speed be? Distance over speed is time. So you could actually say the slope of that is there's constant time. Here's a tricky one. This one is speed and time. But notice, if this was 30 meters per second, 30, 30, 30, 30, this is also constant speed because speed's over here. But what's interesting is, what would the area underneath this line be? As time went on, what would the area be? Well, the area is length times width. That'd be speed times time. What is speed times time? Distance. Believe it or not, you could actually calculate the distance by doing the area underneath that line. Now, you already know from your book that speed is a scalar, so it only has magnitude, like 30 meters per second, and velocity is a vector, so it's 30 meters per second to the right or north, and those are vector quantities. Now, if direction doesn't matter, if I just say a car goes down the road at 30 meters per second, and the direction doesn't really matter, then sometimes you'll see the words speed and velocity interchange, and you can do that if direction doesn't matter. Okay. Now, what I'm going to do is, let's go to non-uniform motion. And non-uniform motion means that you're accelerating. Now, acceleration, the definition is a change in your velocity over time. A change in your velocity over time. Now, how do you find the change in anything? It's the final velocity minus the initial velocity over time. And you've done some calculations in your book on that. To cause accelerations, you need to have a net force. We learned that in the equilibrium chapter. Now, how do you see acceleration? You're either going to be speeding up, slowing down, or changing your direction. So in a car, there are 3 controls that can do that. The gas pedal can speed me up, the brake pedal can slow me down, and the steering wheel can also change my direction. Now, this is interesting in the book. They had a car going in a circle at 30 meters per second, or whatever speed they were going, and it was going in a perfect circle. Now, does he have constant speed? Yes, the speedometer keeps saying 30, 30, 30, 30. But does he have constant velocity? No, because in this case, the direction part of him is constantly changing. It's constantly changing. He actually has constant acceleration. Now, this acceleration doesn't show up as an increase in his speed because it's directed toward the inside. That's for another lesson. Acceleration is very tricky. First of all, these up here, if you look, it has one distance unit and one distance unit and one time unit. One distance unit, one time unit. That's pretty easy. But look at this one. All acceleration units have one distance unit and 2 time units, like that. Now, that's what makes it a little bit tricky. Also, how do you understand an acceleration unit? Well, what I want a little trick for you here. Here's another acceleration, 2 miles per hour per second. 2 miles per hour second. What does that mean? We'll cover up the last time unit, and it means my speed will change by 2 miles per hour. How often? Every second. What about this one? Let's cover this up. My speed will change by 4 meters per second. How often? Every second. Now, that's how you can actually understand acceleration units, okay? Now, here's some things about acceleration. Look at this object here. If we look at it every second, notice that it's covering this distance, then more, then more, then more. If you start covering more distance every second, you must be accelerating. Now, if I went backwards, it would be decelerating. See that? I can even turn it on its side. What if you were to shoot an object up in the air? It would go really fast, and you start slowing down, slowing down, slowing down, and come back and speed up, and that's for another lesson called free fall. Now, acceleration can never tell you how fast you're going. Now, for example, here's a plane traveling at 700 miles per hour, and the next second 700 miles per hour, and the next second 700 miles per hour. What's the acceleration? Put it in the equation, 0. Now, the object could have been going at 1,000,000 miles per hour and had 0 acceleration. Acceleration can never tell you how fast you're going. Now, I had this before. If this equals constant speed, then what does this mean? This means my speed is not constant. Matter of fact, if you think about the slope here, the slope is speed. Here's my speed. Whoa, here's my speed. Here's my speed. My speed keeps changing. This is called constant acceleration. I hope that helps you for this first lesson. I'm going to show you real quickly a graph here. That's what this page of graph's all about. This was constant speed. What is this one? Constant speed, constant speed. This one's called constant acceleration. So think about those graphs when you're doing that. All right, that's going to be enough for the first video. I'll do free fall in the second video. And this is brought to you by Fini TV. It's just the beginning. And that is a French word, means the end. Okay, you don't hear jokes like that on Khan Academy. All right, see you later.